All right. Good morning, class. How are you doing?
Doing all
Pretty
right.
good.
Okay.
I wasn't able to log into my Aces, so I'm actually had to connect via my history, and just click the previous link.
Oh, Aces is down?
I don't know. Every time I try to log in, it would just say wrong password, and I checked like 20 times trying to log in. It was like wrong login credentials, and I was like, "What? I do this every
that
day."
happened to me like 40 times.
Did you get here through the same way I did, like through your history or something?
No, that didn't happen to me today, but it did happen to me.
Yeah, I was about to call the help desk, but I was like, no, I'll just get it through class and I'll call them later because I don't need it right now.
Aces is working fine for me.
Yeah, I was in there a little while ago too. So, okay, well, we need to get down to business today. We're going to try and finish up partial fractions. So I think we're at a point now. We saw last time that, just basically how to split stuff up using partial fraction decomposition. Now we're going to do, several problems, and I can present you with more of an overall strategy on how to go about these. And this is directly out of the notes here. So the notes here, strategy for integrating rational functions. The first thing that we want to do is inspect the degree of the numerator and denominator. Okay, that means, look at the degree of the numerator, look at the degree of the denominator, and compare them. If the degree of the numerator is less than or equal to the denominator, that means the top degree is smaller than the bottom, then you're just going to move on to the next step, which is the actual partial fraction decomposition. But if the degree of the numerator is greater than or equal to the degree of the denominator, then we have to first do long division and then move on to the partial fraction decomposition. So we're just going to start cranking these examples out. This first example we have here, we're going to do this one here. Yeah, this is what today is about. Okay, so we're going to do this one. So we want to find the antiderivative of this. And of course, we would make sure we can't do it any other way, right? There's other methods. Assuming none of the other methods work, I realize it's a rational function, right? The degree of the numerator is 3. The degree of the denominator is 1. So it says that if the degree of the numerator is bigger than or equal to the bottom, we have to do long division first. So I need long division. So what I'm going to do over here is start my long division out using a big division box. And then inside the division box goes the numerator. And when I write this, I'm going to write it in descending order, x cubed. Now I do not have any x squared terms, so I'm going to put a 0x squared. And then I have an x term, so I'll put plus x. So it's important that I made a space for the x squareds in case I get any through the long division. On the outside, I put the denominator in descending order. And then we do long division. So the way we do this is we look at the x here, we look at the x cubed here, and we ask ourselves, what do we multiply x by to get x cubed? So in this case, x squared, right? And it doesn't matter where you put it. I'm just going to put it here, x squared. And so what we're doing is we're multiplying x squared times both of these terms. So the x squared has to multiply here and here. So we multiply x squared by x, we get x cubed. And then we multiply x squared times -1, and that gives us negative x squared. And notice, see, I had to put it underneath the x squareds. And had I not put that 0x squared in there, you would have nowhere to put that minus x squared. So any questions on that step? Now what we do is come through and subtract this row from the top row. And when I do that, it changes the sign. So this becomes minus, this minus becomes plus. So I'm subtracting the row, which means we're going to wind up adding these together and getting nothing here. These cancel. And then here we get 0x squared plus x squared. That's just x squared. And then we have over here, x plus nothing gives us just x. And then we play the game again, right? We say, what do we multiply x by to get x squared this time? So we need to multiply x by x. So I put x up here. And then I distribute that x to both of those again. X times x gives me x squared. I put it underneath the x squared. And then x times -1 gives me negative x. I put it underneath here. And now I come through again and I subtract. So I subtract here, changes this to add. And then I go down again. So these go away. And then 2x. Am I going too fast or is this okay? We all right? We're all okay? Okay. I keep going, right? What do I multiply x by to get 2x? Well, 2, right? So I multiply, do plus 2 here, and then I'm going to distribute the 2 through to each of those. So I multiply 2 times x, I get 2x. Multiply 2 times -1, I get -2. And I come through and again subtract. So I change the signs. Minus here, plus here. Those cancel, I get 2. And this is where I'm going to stop, because I can't turn x into 2. So this is my remainder. So what I do up here is I put plus the remainder 2 over the divisor x minus 1. And that's it. That is the long division of that rational function, which means this original integral can be rewritten as this. It's x squared plus x plus 2 plus 2 over x minus 1 dx. And this integral I'm happy to work with, right? This is good because I have addition between these, so I can do antiderivatives of these term by term, one at a time, right? And so I just look at them and I say, can I find the antiderivative? Well, yeah, x squared, I know the antiderivative of x squared, I know the antiderivative of x, I know the antiderivative of 2, and this is a constant over linear. So we talked about the things we need to be able to do. That's one of the things we need to be able to do. So would y'all agree I'm there? I'm ready to do an antiderivative. No more work to do. No partial fractions here. It was just long division and we're there. Antiderivative is 1/3 x cubed plus 1/2 x squared plus 2x plus 2 natural log of x minus 1 plus c. On that last one here, what I did is I looked at it as 2 times 1 over x minus 1. And then I brought the 2 along for the ride, and then I just used the antiderivative to get the natural log piece there. And I didn't have to scale it because I had a 1 in front of that x. So I didn't have to scale anything out here. Does that seem pretty straightforward? Long division, crank it out. No partial fractions necessary, good to go.
I gotta say, it's been a while since I've had a math problem just leave me with a remainder. You
Yeah,
know? That's like, man, that hasn't happened since elementary school.
yeah, right. You want to write R, like R2, right?
Yeah, no, R2.
Yeah. It's actually, when you think about it though, it's actually a little bit interesting, because if you go back to elementary school and you did 13 divided by 2, let's say, right? You would go 13, 2 here, and you'd say, okay, 2 goes in there 6 times, you put a 12 here, and then what do? We subtract, right? And we get 1. 2 doesn't go into 1, so we usually would write in elementary school remainder 1. But technically, well, that's what you first learn, and then you learn to not write it that way, but to write it this way, 6 and a half, right? Does that look familiar? You write, instead of 6 remainder 1, you do 6, and then you do the remainder 1 and you divide it by 2. What a lot of people don't understand is that that really means 6 plus a half. That's really what 6 and a half means. It's 6 plus a half. If you don't believe it, just get a common denominator here. 12 over 2 plus 1 over 2 And that gives you 13/2, and you're back to where you were. So that's why we hate mixed numbers. Calculus students hate mixed numbers because, first of all, they're too basic. We would rather write 13 halves than to write 6.5. But more importantly, people don't understand what the hell that means. A lot of people think that means 6 times a half. Because really, if we don't put anything between two things in higher level math, don't we mean multiplication? But not here. So it's confusing. Like, why not just put the plus? We should just write it this way. But you know what? Let's just do that then. So we throw mixed numbers away at some point. And
we could do
that's
the-
why. Go ahead.
Or you do the ultimate taboo and turn that thing into a decimal.
A decimal. Yeah,
Which
just
once you get
calculate.
this point, it sure seems like people don't like decimals.
Yeah, we don't like decimals in calculus. We like to have improper fractions instead. Okay, let's look at this one. Oh, by the way, part B, we did that last class. Okay, that's why I'm not doing part B. We did that problem already. So we're gonna do part C now. Or example C. Doesn't that look like a mess? Doesn't that look like an absolute mess? All right, here we go. Let's start the clock. You know what? I forgot my watch. Let me go grab my watch. You start the long division on that. Y'all see we have to start with long division here? Start setting it up. I'll be right back. By the way, I just got a call that my mom is bringing my daughter home from school. She's not feeling well, so you're gonna hear my dogs go crazy and stuff. It's because she's gonna walk in the front door and freak them out. So just FYI, it's gonna be noisy here at some point. All right, so here we go. Long division box. Okay, x to the 4th in here. I don't have any x cubed, so I need 0x cubed. I have a minus 2x squared. I have a plus 4x and then a plus 1. So again, very important to put that 0x cubed in there to give ourselves a column for any x cubes in the event that we have them. We may not have them, but we want to have space for them. Okay, put the denominator on the outside and then start playing our game. So we need to turn x cubed into x to the 4th. So I have to multiply by x. So I'm just going to put x up here. And now that x has to distribute to each one of these. And then I put those answers underneath. So x to the 4th minus x cubed, right? I am going to get an x cubed. So minus x cubed minus x squared and then plus x. And then don't forget the critical step, right? That you need to subtract this row, which changes all the signs. Minus, plus, plus, minus. And then add down. What do I get when I add down?
X cubed minus x squared plus 3x plus 1.
X cubed minus x squared. What do you say?
Plus 3x
Plus 3x plus 1.
plus 1.
Good. All right. Can we continue the long division?
Yeah.
Yeah, we can keep going again, right? Oh, got to sneeze. Hold on. There might be another one of those. Okay, so I'm going to multiply by 1, right? Or I'm going to need to put a 1 up there, plus 1. So that I can distribute the 1 through here. So we should get x cubed, 1 minus x squared, and then minus x, and then plus 1. Come through, change the signs again, minus, plus, plus, minus. What are we left with?
4x.
4x. Right, everything else went away, right? Just so happened that's what happens. So, all right, that's where we are. We have 4x. We can't turn x cubed into 4x, so that's our remainder. So I will put plus the remainder, 4x, over the divisor, which is x cubed minus x squared minus x plus 1. We good? Okay. The original integral now turns into this new integral, x plus 1 plus 4x over x cubed minus x squared minus x plus 1 dx. The first two terms, I'm happy to find the antiderivative of, right? No problems here. The last one, that's not a natural log, right? That's something complicated. So I'm going to go ahead and just go straight to this. I'm going to say, okay, I've got 1/2 x squared, that's the antiderivative of x, plus x, that's the antiderivative of 1, plus some antiderivative I've yet to determine, which is the antiderivative of this. Right? That's where we are. This remaining integral is a rational function. It's 4x over some other polynomial. But now the degree of the top is less than the degree of the bottom, right? So there's no more long division to do here. So now I can try partial fractions on just this piece. So I'm focusing all my attention now on this right here. And I'm going to go to the side here and start my partial fractions. So I'm going to take, this is just algebra. I'm not doing any integration right now. I'm just going to do the algebraic part here. So I'm going to take this. I'm going to see if I can factor the bottom. Can you factor the bottom? Maybe we should factor the bottom first. If we had x cubed minus x squared minus x plus 1, if I asked you to factor that, you would have to use grouping to factor this. Ring a bell? You look at the first two terms, you factor something out. And then you look at the second two terms and you factor something out so that whatever you get when you factor something out, these two things have to match. So I have to pull
Negative
a negative
one.
one. Negative 1 out to make it match. This is called grouping. And as a Cal 2 student, I would expect that you know how to do that. If you don't, you should go get that patched up quickly. This turns into x minus 1 times x squared minus 1. But the x squared minus 1 can turn into x plus 1 times x minus 1 because that's a difference of squares. And now I notice I have two x minus 1 factors. So I can write that as x minus 1 squared times x plus 1. That all makes sense, everyone? That is just me factoring the denominator. Questions? Okay, now I'm ready to write this. This is 4x over the factored version that I just got, x minus 1 quantity squared times x plus 1. All right, so now I'm going to do my partial fractions. I'm going to say that this must be equal to, and now I look at my denominator, right? I've got right here a linear factor, right? It's a linear factor, x minus 1, but it's repeated because it's squared, which means I have to put over here some number a over the linear factor x minus 1 plus some other number b over that linear factor squared. And that's where I stop with that first factor because I've gone from x minus 1 to x minus 1 squared. Then I have another linear factor, right? A distinct linear factor, x plus 1, but I only have one of them. So that means I'm just going to need a c over x plus 1. Questions on that? We now need to find a, b, and c. So here's where you would multiply both sides, right? We're at this step here. Here's where I would multiply both sides by my common denominator, this thing right here. So I'm going to multiply the left side of this by x minus 1 squared times x plus 1. And then I have to multiply the entire right side by x minus 1 squared times x plus 1. On the left side, I'm left with 4x. And on the right side, we just have to be careful here. When we multiply this to this, one of the x minus 1's cancels, right? One of them. Because I have an x minus 1 on the bottom, and I have 2 factors of x minus 1. So one of them cancels, but I still will have the a. I'll still have one of the factors of x minus 1, and I'll still have the x plus 1. Any questions on that? It's just algebra. We're good. Next one through, both x minus 1 factors cancel. So I'm left with plus b, and since both x minus 1 factors cancel, I'm left with b and then the x plus 1. And then on the last one, when I multiply through c, the x plus 1 cancels, which leaves me the x minus 1 squared still there. Now, I showed you last time that when you're doing this, trying to find what A, B, C, whatever you're looking for, that there's a short way and a long way, right? Let me go back here. This was the short way, right? Where we just figured, we said, oh, let's try and get A. So we killed off the B and the C terms. And then to get B, we killed off the A and the C terms. And then to get C, we killed off the A and the B terms. That was the short way. The long way, did I do this the long way in class? I think I did this with a student after class, right? Lewis, we did that, right? Okay, so I have not shown you the long way yet. I'm going to. But on this one, I want us to first try the short way. The short way would be to see if there's a way that we can figure out what A, B, and C are. So let's try and find A. If we try and find A, what we'll need to do is try and kill these two off. When I say these two, I'm talking about the entire terms. Is there a value of X that you can plug in that will kill both of these off simultaneously?
-1.
-1 would kill this one off, right? It would kill this one off, but it wouldn't kill this one off, would it? See what I'm saying? I could kill this one, but it won't kill that one. If I let X be -1, this goes to 0, but that doesn't. Y'all see that?
We could
Okay.
find B and C pretty easily, though.
Okay, yeah. So it looks like to find A, it won't be possible for us, right? We're not going to be able to find A because there's no way to kill both of those off. It's very important you understand that. Does everyone understand? You could kill this one off, couldn't you? By letting X be 1, but it won't kill that off then because it makes that 2, right? 1 plus 1. So there's no way to find A easily. Okay, well, that's all right. Let's try and find B. Can we find B? Well, to
Set
find
it
B,
X equal to 1. It kills off A and C pretty easy.
try and kill this one and this one. So if we let X be 1, it turn this to 0, and 1 will turn this to 0, and it won't do anything to this. So let's do that. Let's let X be 1. Okay, once we let X be 1, we rewrite the entire thing. Everything gets rewritten with X's replaced with 1s. So this becomes 4 equals, now I already know that when I plug 1 in here, it's going to kill all this off, but I'll still have B and then 1 plus 1. And I also know that when I plug 1 in here, it's going to kill all that off. So that's all I have. 4 equals 2B. Divide both sides by 2. You know what B is. All right, great. I know what B is. Let's find C if we can. to find C, is there a way that I can preserve this one, but kill both of those off?
Put in a -1.
-1 for X. And then again, rewrite the whole thing, replace all the X's with -1s. So we should get -4 this time because I replaced that X right there with -1. We know that -1 in here is going to kill this off. We know that -1 in here is going to kill this off. And over here, we're going to get C -1 minus 1 squared, which is -4 equals, let's see, -1 minus 1 is -2. -2 squared is 4. Hey, everyone, hold on. Let me just check my daughter real quick. Okay. All right, so just divide both sides by 4, you get C is -1. So now we know what A and B, what B and C are. But we still don't know A, right? So how are we going to get A if we don't know? You know what I'm saying? Like, there's no way to get it. You have different options. At this point, you have different options on how to proceed. I'm going to do it by showing you basically the long way to do this. We're going to kind of, this method, what I'm going to do is blend this short method. We're going to use this information that we have right now to help us, but I'm going to just now go down the long way path just to show you what it's like, right?
Look, Professor, can't we just insert those values that we already know?
Yes, you could.
Okay.
You could just insert those, okay? You could insert, B is 2 and C is -1. And then you could plug in some arbitrary value for X and you would then find A, all right? So you could do that. But what I'm going to do is a little different. I'm going to take this. Y'all ready for this? I'm going to take this here and copy it. Let me go to a new page. I'm going to approach this as if we were trying to find A, B, and C right now, and we didn't know what anything was, okay? We didn't know what anything was, but we realized, there was no way we could have gotten A, right? Here's what we do. We will multiply everything out, okay? So that means I'm gonna FOIL that together. I'm gonna distribute the B through. I'm gonna expand that out. Let me do this. This becomes 4x equals A, and then when I multiply those two out, I get x squared minus 1. I hope you're comfortable with the idea that this FOIL becomes x squared minus 1. Yeah. Plus bx plus b, and then over here plus c, and then if I multiply x minus 1 times x minus 1 and expand that out, you'll get x squared minus 2x plus 1. Now I'm going to distribute the A through and the C through. So I get this line, 4x equals ax squared minus a plus bx plus b plus cx squared minus 2cx plus c. Any questions on that? You'll see where I'm going here in a minute. Next thing I'm going to do is I'm going to collect all my x squared terms, put them together, all my x terms, put them together, and then everything that doesn't have x and put them together. Right? So I'm just going to rearrange things. 4x equals ax squared plus cx squared plus bx minus 2cx minus a plus b plus c. So there's my x squared terms. There are my X terms. There are my things that don't have X, right? Again, you'll see where I'm going here. Next step. On the yellow terms, they both have X squared. So I'm going to factor an X squared out. Normally, if you were to factor an X squared out of this, you'd put X squared and then you would put A plus C, right? Like that. That's what you normally do. Factor an X squared out of both of those. I'm going to do the exact same thing, but I'm going to write it backwards. Put A plus C in front of X squared. It's the same thing, because if I distribute this through, it would still give you AX squared plus CX squared. I'm going to do the same thing for the B minus 2C. I'm going to pull an X out of both of those off to the side on the right. And then on the last ones, I'm not going to factor anything out, but I'm going to write it in parentheses like this. Any questions on that? Now, why did I do all that? Here's
Can
why.
we,
Yep.
can
What?
we treat that like a trinomial and factor it?
I see what you're saying.
Mm.
Yeah, if you could, well, it wouldn't always have to be, this just coincidentally turned into a trinomial, like a quadratic trinomial. No, what we want to do is actually is a little easier. Look, on this left side is 4x, right? It's 4x. So do you agree the left side is really 4x plus nothing, and in front of it, we have no x squareds? There's no x squareds plus 4x plus 0. I know that seems strange, but look, if these two sides are equal, then the number in front of x squared here must match to the number that's in front of x squared here. These two have to be the same. The number in front of x must match with this number in front of x. And finally, the number that's by itself that doesn't have x's must match with the things over here that don't have x's. Do y'all see that connection I've just made? That allows me to write 3 equations and 3 unknowns. So let me write the first one. I know that A plus C has to be 0. I'm going to write it this way. A plus C has to be 0. That's the first equation I know. The second equation is B minus 2C has to be what?
4.
4. So B minus 2C has to be 4. And finally, I know that negative A plus B plus C has to be 0. Negative A plus B plus C has to be 0. And now I have a system of 3 equations and 3 unknowns. And in college algebra, we learn ways to solve that. Y'all with me? Now, going back where we had started with this problem, we started trying to use the short method, and we were able to figure out what B and C were, right? We just didn't know what A was. So then I showed you this long method. But see, if we do the long method and we get to this step, and then we actually use what we already know, right? We know that B is 2 and C is -1. I can put here, but I know from earlier, B is 2 and C is -1. I should be able to figure out what A is from this, right? Couldn't you just take this first equation and just say, oh, well, if A plus C has to be 0, and I know that C is -1, I can replace C with -1 and then add 1 to both sides. Then I know what A is, right? But the only way I would have known that is to actually work this all out and set up the equations. So now I know what A, B, and C are. Yes? I don't claim that you should be happy about this. This is a lot of work, okay? But do y'all see what I've done? Okay. Let's take a little pause here. I feel bad because I meant to tell y'all to bring your graphing calculators today if you have them. But since you're at home, you probably have them close by. So I want to take a poll real quick. First of all, the poll question is, how many of you actually have your calculator with you today? Your a graphing calculator with you today? We'll make sure there's enough of you. to
It's
make it work.
it's like right over there on my bookshelf.
Okay. Okay, so almost everyone. 4 of you don't, it's okay. Okay, now, next question. Is your graphing calculator a Texas Instruments? Yes or no? Okay, so there's 3 of you who said no. What kind do y'all have?
I just don't have a graphing calculator in general. I just have a scientific one.
Okay,
Same
that's
here.
fine.
I only have a Texas Instrument
Okay, but it's
TI
not that.
30X.
Okay, okay.
Cal one set nah. So
So,
It doesn't
so
bother.
3 who said no, 2 of you just don't have a graphic calculator. Eduardo, were you trying to show me something? No, okay. Is there anyone using like a Casio graphing calculator or no? Everyone else pretty much has TI?
Well, I have a Casio graphing calculator and it appears to be dead, so
Okay, so you don't have you don't have a TI?
no.
Okay. So I'm not going to tell you that you need to go invest in a Texas Instrument calculator. All right. I'm not going to tell you that. It's not required for the course. But if you are a STEM major, which most of you are, I would suggest that at some point you invest in a graphing calculator. TI 84 plus is like, you know, good enough to get you through college. Okay. TI 84. If you want to go and get something fancier, go ahead. I would just be careful not to don't buy something that has a computer algebra system. So the TI 89, the TI Nspire CAS, if it says CAS on it, you might want to avoid those because you can't use those on standardized tests. And you can't use them on in some classes. Like I usually don't allow people to use those because it does integrals and derivatives like symbolically. So it's way powerful. Anyway.
sir,
Yeah, go
sorry
ahead.
if I interrupt. You said a TI 84 plus.
TI 84 plus is like, you can get that at Walmart. You know, they're not cheap, but they're not super, well, I don't know, nowadays everything's expensive. So, but you can probably find them used, you know, people finish college and they sell their calculators and stuff. So you might be able to find something used on, you know, Marketplace or something.
Okay, cool. Thank you. I'll be
But I
looking forward.
recommend TI only because that's like what 99% of people use. And so if you're working with people on things, you want to have the same inputs. Casio is there's just not many people using Casio. And so you have a lot of issues with people not knowing how to do certain things on Casio, where like everyone knows how to do it on TI. Okay, so with that said, and the fact that there are, you know, 10 out of 13 of you have Texas Instrument calculators with you right now, I want to show you how to solve a system of equations in your calculator so you don't have to do it by hand. All right, and on a test, I don't mind you doing this. Okay, now let me preface this whole thing with this. There are many ways to do this on the Texas Instrument calculators. But the thing is, Texas Instrument calculators have different user interfaces depending on what model they are. So the TI 84 has a slightly different interface than the TI 86. That has a slightly different interface than TI 89, the TI Nspire. They all have different interfaces, but they all have the same built-in functions. So the way I show you to do this is designed to be able to be done on any of the TIs. So if you know how to do this a different way, do it that way then. I'm not here to reteach that. I'm just trying to give a universal way of doing this for all of them. Understand? Okay, so I have a handout. It's in our files, course files for our class. This is it's called the RREF instructions. So go into course files, go into formulas you can use on a test. This is in here. And what it does is it walks you through how you can solve a system of equations using your calculator, your TI calculator. So let's say we wanted to solve this equation here. It's the system of equations. It's 3 equations with 3 unknowns, right? We don't know what X, Y, and Z are. The first thing that we have to realize is that this can be rewritten as what we call an augmented matrix. Don't worry about what's an augmented matrix. I haven't taken linear algebra. Don't worry about all that. Just realize all it is the coefficients of the system of equations written down, 3, 1, 1, 4. And you have to make sure that you're in order, X, Y, Z, and then equals the other side. 4 is the number over here. Then X, Y, Z, put them in order, and 2, -4, -2, 2. And then the last one is 1, -1, -1, 0. So you convert your system of equations into what's called an augmented matrix. That kind of makes sense? Go from the system to the augmented matrix. Once you do that, you're going to locate and select the RREF function in the calculator. Now, this is in a different place on different calculators. On some calculators, it's under the math menu, and on other calculators, it's under the matrix menu. So if you have your TI calculator right now, try and find the math or matrix menu, and it'll bring up a list of functions. And then within there, you know what? I don't think I have my emulator up and running right now. No, I don't have my emulator running up. Let's see. So try and bring up the menu. So for my calculator, I bring up, where is it? I bring up my math menu. And then I have to go to matrix. And then if I go to matrix and scroll down, I see a thing that says RREF with a parenthesis. Anybody having trouble finding that? Now speak up, please. Everyone's found it? Yes, yes.
I haven't found it, sir.
No? What kind of calculator do you have?
The TI-84 Plus.
Plus, okay, so I think on the plus, do you have a key that says math or matrix on it?
I have one that says math.
Math, okay, when you click on math, what does it bring you? What does it show you?
But you know what? I just found it. It's right
You found
under
it?
Math, yeah.
Okay. And you see the RREF? You might have to scroll down. You got it? Now be careful, there's an REF and there's an RREF. Make sure you do RREF. If you take linear algebra, you'll find out that that stands for reduced row echelon form. That's what the function is that's what it is, the reduced row echelon form function. So what we do is we hit enter or select RREF, and it should pop up on your screen, you know, RREF with the parenthesis, and you should have a cursor blinking. And it's basically waiting for you to put in this matrix. And so I'm showing you how to type that in. If we want to put this matrix in, we have to use a bracket, not a parenthesis, not a brace, a bracket. The bracket is usually above the comma symbol. You do a bracket that starts the matrix, then another bracket that starts your first row, and then you put in the numbers of the first row with commas between the numbers. And then you close that off, open up a new bracket, no comma between those, and then you do the next row and then the next row. And then you close it off, close everything off, and then you close the parenthesis. After you've inputted that, you hit enter, and it should spit out this right here. It should be 1 0 0 then a number, 0 1 0 then a number, 0 0 1 then a number. These three numbers are the solutions, X, Y, and Z. quick poll. Let me know yes when you have typed it in and you got those answers.
I actually have a feature like that on my Casio, where I was able to put in
Okay,
those
great,
numbers. and,
great. Does the Casio handle systems of equations higher than three equations, three unknowns? Do you know?
yeah. It goes up to 4.
Four, okay, so if we ran into a 5, you would run into an issue.
Yeah.
But at least you have it up to 4. That's good.
Hey,
Yeah.
Arturo, what kind of calculator do you have exactly?
It's a Casio FX 991EX class whiz.
Okay, because I have an FX 7400G plus, so I need to mess with it to get it to actually work, because I think its batteries are busted,
Okay.
so.
Yeah, it's just whatever I could find in the Walmart bin, so.
This is my dad's old one that's been sitting on my shelf for the past 6 years because I haven't been allowed to use it in any classes.
So I have 2 people have said no. Are you having trouble getting that, or is that a different reason?
I just don't have one.
a
I
calculator.
shouldn't have
Okay,
pressed
you
it.
just don't have one? Okay, that's okay. If you don't have one, just, don't worry about it right now. I just want to make sure that people who do have it are getting the answer.
Yeah,
Or
I have the
getting-
matrix up, but where's the RREF button? Where do we find that?
What calculator do you have?
The TI 84 plus.
Okay, so I think it's under, is it, Ricardo, you said it was under the math menu, right?
Yes, so it was second, and then under the math button, there's the matrix.
Yeah, so go math, then hit matrix.
There's like a little ribbon on top. There's names, math, and edit. You scroll down on math, and then you'll find, I think it's gonna be, it'll be letter B, it's RREF.
Jonathan, you seeing it?
Okay. Yeah, thank you.
Okay, good. This is much easier to do in class. Like, normally I just walk around and I just like help people find it, and then it's all good. Okay, so with that in mind, if we go back to this problem here and we act like we never did this short way, okay, and we just got right down to this right here, then what I could do is I could go and convert this into the augmented matrix, put 1 0 1 0 0 1 -2 4 -1 1 1 0, right, pulling the coefficients off of this, and then do my RREF in my calculator here. And if I do that, I should get 1 0 0 1 0 1 0 2 0 0 1 -1. And there are my solutions, A, B, and C. So let's take a minute. I think it's important enough. Why don't we take like 3 minutes, 4 minutes, and see if you can put this matrix in and get these answers. Hunter, you have a question?
Yeah, I was gonna ask, to solve this manually, wouldn't you solve the top 2 equations for C and then substitute what you got in?
Yeah,
for,
there's different ways. There's different ways to go about this. You could
You'd solve
the first one for A, and
then
then
second
plug
one
that
for
in
B,
here.
and then substitute in,
Yeah.
and then you can solve for C, and then you can use that to get the other 2 easy.
See, this system is actually pretty simple, right? This is not a complicated system because there's a lot of missing stuff, right? This one's missing a B.
Yeah.
This one's missing an A. It makes it easy to solve. But if there's A's, B's, and C's in all of them, it's
It
going to
gets
take you a
crazy.
while. It's going to take you a while to solve the system
Yeah.
using an elimination.
I'll get my calculator working, or get another one that works if this one's just busted. And then I'll figure this. This is a printout that you have, right?
Yes.
Okay. I will come back and look over it once I have my calculator working.
Okay. Take a minute. I'm going to refill my drink. Tell me yes. Tell me yes when you get the answer to this, because there's about, I think, 10 of you here that have a calculator that I think you've figured it out. Just give me a yes when you've gotten these answers 1, 2, -1 off of that matrix. Be right back. All right, everyone. You all ready to move on? Any questions? Anyone having trouble with the calculator? All right, let's take a look at this one then. Rational function. We do not need long division, right? Because the degree of the numerator is smaller than the denominator. So the first thing I'm going to do is factor this denominator if I can, and then see what kind of partial fractions I need to do. So let me do that on the side here. I'm going to factor the denominator. I think that this is a pretty easy one to factor. I hope you agree that all I have to do, all I can do really is pull an x out. Then I get x squared plus 4. Right? That's all I can do. Can't break down the x squared plus 4. So I look at the denominator. I see that I have a linear factor, right? And because I have a linear factor, I'm going to need a over x. And then I look at the other factor, and that is an irreducible quadratic. Irreducible meaning I cannot factor that, right? Irreducible. It's quadratic, x squared plus 4. And so this is where we need to remember from last class. If you ever have an irreducible quadratic, you're going to put the irreducible quadratic on the bottom, and on the top must go a linear expression. So you must put here bx plus c. All right. Good. Now we just play the same game. We multiply both sides by common denominator. I know the left side's not going to change, or I'm sorry, all I'm going to get is the numerator. On the right side, when I distribute through this first distribution, the x's canceled, but the a is still there. And the x squared plus 4 is still there. And then when I distribute here to here, this one's tricky. The x squared plus 4's cancel, but I still have the x and I still have the bx plus c. So I'm going to write it like this: bx plus c, and I still had the x there. Do you understand that cancellation on that second one? All that really happened was that and that went away, but that x must still distribute to both of those terms. Now, looking at this right off the bat, I don't think it's going to be easy to get things, because I can never make this go to 0. Do you all agree? X squared plus 4, I can never make that go to 0. No matter what number I ever plug in, it has no real solution. So I'm just going to go to the long method right now, and I'm going to be prepared to do a system of equations.
We could solve for a though.
You could solve for a, yeah. But the algebra to get to the long method isn't that long, right? We're just going to go 2x squared minus x plus 4 equals, distribute the a through ax squared plus 4a, distribute the x through bx squared plus cx. Now I'm going to collect my x squared terms together. That's these two, right? Those are the only x squared terms I have. I'm going to put them together, and I'm going to factor the x squared out. So I'm going to have an a plus b and then x squared. And then I'm going to look for my c terms. Not my c terms, my x term, that's the only x term I have, which is plus cx. And then I'm going to look for anything that doesn't have x in it, and I have a plus 4a, so I'm going to put that back here, plus 4a. And at this point, I can play the matching game, right? The number in front of x squared, 2, must match the number in front of x squared over here. So that tells me right now, a plus b has to be 2. And then I have a -1 sitting in front of x, so I know that -1 must match up with, must match with what? C, right? So I know C right now. C is -1, right? And then the last thing is I know that 4 must equal 4a. So 4a must equal 4. Now, you could do a system of equation. You could do the augmented matrix here, couldn't you? Right? If you did the augmented matrix, it would be 1, 1, 0, 2, 0, 0, 1, negative 1, 4, 0, 0, 4, and you would do your little thing RREF. But we don't actually need to work that hard for this one. Do y'all agree?
Divide that bottom row by 4.
Yeah, this right here is C is -1. We're done with that. Then on this one, if we divide both sides by 4, we get A is 1, right? And now to get this one, I already know that I know that A is 1, right? I just found that A was 1. So I know that this is really 1 plus B equals 2. And if I subtract 1 from both sides, I get B is 2. Oh shit, hold on a second. Wait a minute, did I not finish the last problem? Crap. Y'all didn't let me finish the problem. Y'all let me move on without finishing the damn problem. Why didn't y'all say something?
Thought we were supposed to do it ourselves, you know?
Yeah, you know what? Okay, let's pause. We'll get back to
Fine.
it. Okay, let's finish this one.
Do it manually. All right.
Wouldn't it be B equals 1?
Yeah, I don't know why I put 2. I think I said 1, I wrote 2. I think that's when my brain was having a flash that I forgot to finish the other damn problem. All right, we good? Questions? This integral now turns into, all right, A over X, right? A over X. And we said that A was 1. So 1 over X. Ooh, I'm happy about that. I can find the antiderivative of that. Plus now B was 1, so 1x, so that's just x, plus C, but C is -1, so I'm going to put x minus 1. And then over x squared plus 4 dx. With me? First one, antiderivative, no problem. Antiderivative of 1 over x is natural log x, right? Plus, now this one's going to require some work. I have a linear over an irreducible quadratic, right? Linear over irreducible quadratic. And there is a certain way we attack this, right? I'm going to notice right now, and hopefully you'll notice the same thing, that if I split it into 2 right now, I'm allowed to do that, yes, that's just algebra. If I split this into 2 integrals, it's the x over this, and then minus the 1 over this. Do you all recognize this one? Antiderivative of that, we'll use what? No?
There's a lot of Trig.
There's a lot of things coming up.
Yeah.
Here.
Trigonometric.
Yes.
You could do trig sub, but this one, if we go back to what, way back here, beginning of this section, do you remember this very important formula for arctan? Right, we can use this right here. Right, so I know I can do this one with formula 17. Right, formula 17, I can do this one. And then this one, you know how to do this one?
That's just U sub.
U sub. Basic U sub, because if you look at the denominator, x squared plus 4, if you take the derivative, you get 2x, and we have an x on top, so we're off by a constant.
It should just become natural log of x squared plus 4, right?
Half of natural log of x squared plus 4. Because you have to account for the 2 that comes out with the U sub. Let me keep going. Natural log absolute value of x plus, okay, let's do this. I'm going to leave this integral alone. I'm not going to do it yet. But on this one, minus, on this one, I'm going to go straight to the formula 17. I'm going to do the antiderivative. Here for us, a is 2. And formula 17 is when you have 1 over u squared plus a squared is 1 over a arctan of u over a. for us, u is x. So this will be 1/2 inverse tangent of x/2. I'll have a plus c. This integral I would do u is x squared plus 4, du is 2x dx. I have an x dx, so I have to scale by 1/2. And if I rewrite that integral, it becomes 1/2 1/u du. Replace the x squared plus 4 with u, replace the x dx with 1/2 du. This is 1/2 natural log of u, but that's just 1/2 natural log of x squared plus 4. So that's this one. 1/2 natural log x squared plus 4 minus 1/2 inverse tangent. What do y'all think? What are y'all thinking right now?
It's not that bad.
No? That's one voice. How about it? Anyone else have a different opinion?
Need some practice.
Yeah. Yeah.
Yes, definitely.
It looks a lot harder than it actually is.
Okay.
To be honest, that's been like most of calculus is you see all these things and they're like, oh God, what the hell is that? And then you walk us through it and it's like, oh, that's all.
Yeah. Yeah, I remember when I decided to become a math major, I remember going to the bookstore back when we had bookstores. And you know, they would separate everything by, you know, like your 1,000 level math courses, 2,000 level, 3,000 level, 4,000 level, then like the graduate, right? Graduate books. I remember walking down to the graduate books and opening them up and looking at them and being like, oh my God. I was like, okay, I'll be able to read this one day. And so by the time I got to it, I was like, okay, now I get it, you know, but when you're looking at it before, it's like a different language.
It's like flipping through to the later chapters of this trig textbook. I'm not the calculus textbook. It's like, geez.
Yeah, yeah. Okay, sorry, I need to come back to this one. I never finished it. I apologize. We had gone through all this and then we finally got to the point where I taught you to do the RREF. We have A is 1. Yeah, let me just copy this. I'll need that. Let me just copy that. So I'm gonna go back up to here, right? Remember, we were here and we broke this integral down to be this. Okay, so I'm focusing my attention on this right here because we did find A, B, and C. Let me just paste it here real quick. So this now becomes, here's where we were. We have 1/2 x squared plus x plus the integral, but all of that broke down to be a over x minus 1. So a is 1. So 1 over x minus 1 plus b here is 2 over x minus 1 squared, and then plus c, but c was -1 over x plus 1, and then all of that dx. And now it's just a matter of, am I comfortable with these as far as antiderivatives? And this goes back to, again, why we spent all this time the other day talking about what we should be able to handle, right? Constant over linear, we should be able to handle that. Constant over linear, handle it. Constant over linear repeated, right? Constant over linear repeated. We were trying to make sure we were comfortable with this because now that's exactly what we have here, right? This is going to be 1/2 x squared plus x plus, okay, the antiderivative of this one is natural log of x minus 1, absolute value, plus, okay, now this one's a little tricky because this is a repeated. So this is where you squint your eyes and you think about, okay, the 2 is going to come for the ride. This is really like a 1 over u squared. 1 over u squared, which is really like a u to the -2. So when you do the antiderivative, you get 1 over -1 u to the -1. That's kind of what you're thinking. But u is actually the x minus 1 to -1. And then this last one is just minus because there's a negative there, natural log of x plus 1 because that's just a constant over linear. There it is. It could be cleaned up a little bit, but I think you get the idea, I hope.
Bit of a messy looking answer.
Yeah. What's kind of weird is to think that when you take the derivative of this, right, when you take the derivative, you should get back this. All right, let's see what else we got here. I know I've got at least another problem.
It's really funny because there's a lot of these where it's like, yeah, I know that the integral and the derivative are like they undo each other. But when you're doing these, I always get the impression that they wrote the integral without the derivative in mind. And oh man, the derivative is a giant mess. Okay. It's kind of like when you're doing derivatives, you don't get things that would be fun or good to integrate at all.
Yeah. I hear you. All right, what about this one? Where do we start?
Well, the degrees are the same.
Okay, so what happens if the degrees are the same? Do we do long division or do we not?
Didn't we do long division if the degrees were the same?
If they're the same, you do have to do long division.
Wouldn't it just be
You
one
do.
with a remainder of,
You're gonna have one with something because, yeah, you'll have to turn 4x squared into 4x squared. So why don't you work that long division out? Okay, take a few minutes, work it out. Let me know when you're done with the long division. Let me know when you're done with long division on that. We've got 6 people done. For those of you who are done, check out what I'm going to do. Okay, most of you finished it. So look what I did. I noticed that this is almost the same thing, right? But I said, this is, this is -3x, not -4x, and this +2, not +3. So I went ahead and wrote down the denominator. I just wrote it up here. And then I just tweaked it so that it's really a negative 3x by putting minus 4x and then plus x. And then it's really a 2 because I did 3 and then take away 1. Now, the reason I did that is because now I can split this into 2 fractions. I can do all of this over the denominator, then all of that over the denominator. And if I do that, I'm going to get the same answer you just got. 1 plus x minus 1 over 4x squared minus 4x plus 3 dx. Is that what you got? Yeah. Now you can't always do this, okay? This only works when these things are almost the same. These two have to be exactly the same for this to work. And then you have to have x terms in both, and you have to have numbers in both. So I'm just showing you it's kind of a cool little like sneaky way to avoid the long division. Okay, but we're at the long division, right? We're here. So now at this point, what we'll do is we can find the antiderivative of each one. The antiderivative of 1 is x, plus now I need to find the antiderivative of x minus 1 over 4x squared minus 4x plus 3 dx. And before you start going crazy with this and trying to do partial fractions, right? I want you to think about what you have here. On top, you have a linear expression, right? And on the bottom, you have a quadratic. The question is it reducible or not? Can you factor this or not? So does it break down to be 2 things or not? And you look at it, let's see, 4 times 3, that's 12. You need 2 numbers that multiply to be 12 and add up to be -4. Can you think of 2 numbers that multiply to be 12 and add up to be -4? Not really, right? 2 numbers that multiply to be this, but add to be this. You could try like 2 and 6, but that won't work because it needs to add to be -4. So you need one of them to be negative. Not working, right? Not factorable. That means it's an irreducible quadratic. And if you look back in our notes, we have a method for doing a linear over an irreducible quadratic, don't we? We have a method for this. In fact, isn't that the same problem? I did that on purpose. That way we don't have to work this problem out, okay? So we've seen this integral before. We've actually seen it, and I'll take you back in the notes for when we did this. What I want you to understand is at this point, you do not want to do partial fractions because it's a linear over irreducible. And so you don't try to do partial fractions. You can only do partial fractions if you can somehow split that bottom up, which you can. Where in the notes did we do it? I'm going to say it was, there it is. This was it. This was the one that I did where I said, I like to do it a certain way. If you go to a tutor, it's probably going to be different. This is where I let u be the denominator, and then du is 8x minus 4, but we don't have 8x minus 4, so I had to make it turn into an 8x minus 4. And then when we did that, we split it into 2 integrals. The first one was a basic u sub. The second one required us to do a completing of the square. We completed the square and we got an arctangent at the end. So that would be the next step. I'm not going to rework this. Okay. All right, we have a lot of time. I'm not going to move into the next section. I'm going to give you 2 questions for y'all to work. These came straight off of an old test. These were 2 problems on the test, back-to-back problems. Now, the test that I gave last fall for the second part, like the second exam, the test was 8 questions. It was an 8-question test. And this was 2 of the 8. So copy those down, take a screenshot, whatever you want to do. And then why don't we do breakout rooms? Y'all want to do breakout rooms? I don't know. I mean, I can. If you don't want to participate, you don't have to, but we'll do breakout rooms and let's go. 15 minutes will take us almost to the end of class. Let's go for like 15 because we have 23 minutes left. I'll pull everyone back here about 5 minutes till about 12:35. And just kind of see how y'all did with this. And good news, this is it. We're done with the techniques of integration. We've got everything now.
Now we just have to remember it all and be able to access it effectively.
Yeah, now you need to know when to use which method. And that's the hard part, right?
I'm excited for whatever portion that starts being the, hey, here's a bunch of problems, figure it out.
Yeah, well, what we're gonna find here pretty soon is that when we move on, is that the integration is not gonna be as hard. Like the problems we do, the integrals aren't gonna be harder. I mean, they aren't gonna require all these methods. Okay, so we've kind of like beaten ourselves to death with this, and now we're ready to move on to applications. All right. I made some breakout rooms. Feel free to join. Have fun.
So I had a question.
Yes, sir.
So I'm done with the matrix. So the last numbers, like on the last column, those are the like the answers, right?
Yes.
I'm confused though. Is it go in descending order for A, B, C, and D? If I did it
Yes.
right, or
If you did it right, if the far left number was your A's, and then the second number was your B's, and the third number was your C's, and yeah, then yes, it'll be ABC.
okay, sounds
It'll
good.
be in that order. What did you get?
So for the matrix, it was 1, 2, 1, and -3.
Yes. Okay,
Was the
good.
first- That was the first
Yeah.
question.
Yeah, good job. Yep.
Thank you.
And you know what? Just, you can still see my screen, right?
Yes. Okay.
So you just, if you think about, if it spits out an answer 1001, 0102, 00, oh wait, hold on, there's more numbers in here. 0, 0, 0, 1. Right, that's what it spit out.
Yes. Mhm.
The way you think about this is your A, your B, your C, your D, and then equals a number. That's what each one of these lines represents. So
Right,
if you think about what 10001 means, it means you have one A, 0 Bs plus 0 Bs plus 0 Cs plus 0 Ds equals 1, which means A is 1.
Right. Okay.
And the next one, the 1 is in the second position, so that's what B is. If that makes sense.
I see it. Yeah.
Okay. Okay, I think mostly everybody's back here now. So how'd that go? Hmm?
It went all right.
It
I'm
was rough.
almost done with the first one.
Yeah.
Did anyone get into the second one at all?
Yeah, did anyone get to the second one? I don't think anyone
No.
got to the second one. So let's talk about the first one here. Let me see, how much do I want to show you? Yes, I can show you everything. Come here. All right, so the first thing you have to do is realize there's no long division, right? There's no long division. And so you're just going to go ahead and start by factoring the denominator, right? And then you look at the denominator, you say, okay, I've got x squared. That's a repeated linear factor, right? It's x, then times x again. So I'm going to put a over x, and then I'm going to put b over x squared. And then the second factor is an irreducible quadratic, so I have to put cx plus d over that. Any questions on that part? You have to have a over x and then b over x squared. If you just do a over x, it's no good. You could have also done this though. You could have looked at this as an irreducible quadratic, and instead of writing this, you could have put ax plus b over x squared. It would still work. Because if you split this into two, right? What would happen if you split this into two? A over x plus b over x squared, which is the exact same thing I did. So it doesn't matter how you look at that one. But once you're there, okay, once you're there, then you have to get your, you have to clear your fractions out, which I didn't show that step, but you get this. And then I went the long method. I just went the long method because I don't think there's any way to get A or B or C easily. Maybe you can. Yeah, you probably can, but I did the long method. Then I got to this and I went to my calculator and I did RREF right there. Questions? It's if you mess up this algebra, it's over, right? I mean, it sucks, but if you mess up this algebra, you're done at that point. Okay, once we have this A, B, C, and D, I rewrite all of this and I get this expression right here. That's replacing my A, my B, my C, and my D with what they were. And then I look at each of these and I say, okay, well, the first one, that's just natural log, antiderivative, right? Second one, well, this is just a power rule, right? This is like 2x to the negative 2. I can do the antiderivative of that. This one is a linear over irreducible quadratic. And I did it a certain way. You could split this into two, just like I did on the problem we did right before this. You could put x over this and then negative 3 over that. You could do it that way. We'll get the same answer. I did it by just trying to make the top look like the derivative of the bottom, and we wind up getting the same answer no matter how you do it. That's the first one. Now, no one got to the second one? Okay. I'm going to talk about the second one, all right? On the second one, I'm going to go through this real quick. You have to do long division first. So you do your long division, you get this. Once you do this, you set it up in the integral. You do the antiderivative of 2, which is 2x. But then you have to find the antiderivative of this big ugly thing. So you go and you factor the denominator. And when you factor this, the only thing that factors is an x. You can pull an x out. The x squared plus 4x plus 1 that's left can't factor. So you have a linear factor, a over x, plus this is irreducible quadratic, so you have to put a linear over it. Then you do your little game, you get your numbers, okay? Once you have your numbers, you rewrite the integral. You replace the a, the b, and the c with these numbers, and you get this integral right here. The 2 over x, easy. This one, linear over irreducible quadratic. This one cannot be done the way I did, the way I said you could do this one. The reason you can split this one up and put X over this and 3 over this is because the denominator, if you let that be U, the derivative of that is going to be nice and clean. It's going to be 2x, and so you're off by a constant. This problem, you can't do that because if you let U be the bottom, then the derivative is 2x plus 4, and you don't have that up here. So this one, on this one, you have to do the way that I showed you to do, right? Which is to let U be the denominator. Here's the derivative of it. And then you have to turn x plus 3 into 2x plus 4. And so you do this thing, and then you're going to wind up doing an easy integral and then a completing of the square integral. And then you're going to go to a formula. See, I have it, formula 20 right there. Both these problems were on the test. Out of 8 problems, this was 2 of them. So you can see that time, right? These take time. So the more, I guess, the more comfortable you are with like recognizing what to do and like executing the steps and procedures, the better off. If it takes you 35 minutes to get through this problem, 40 minutes, you're going to run out of time, right, on the test. Would y'all like to see the rest of the test? I'll show you the rest.
Why not?
Yeah.
Oh, you know what was wrong? This was a review. I apologize. This was a review for the test, but the test did turn out to be eight questions. I don't know why the review was only 6. So the first integral here, trig sub, right? Trig sub. Second one, trig sub, different trig sub. Oh, I should mention on this first trig sub one, you're gonna have to pull the 9 out to start, because the formula won't work unless that's a 1 in front of x squared. So you got to pull a 9 out. The 9 comes out as a 3, comes out as a 1/3. Then you can start doing your trig sub. The second one is another trig sub, but it's a plus between these. You don't have to pull anything out, so it's nice. God, that thing is annoying. Why is it doing that? The third one is a linear over an irreducible quadratic. Oh wait, yeah, that's irreducible. But it also has numbers here. So we will talk about that next class, and then you'll be able to do this later. But you still have to find the antiderivative of this. So you can imagine what you have to do for this. That's the one where you try and make the numerator look like the derivative of the bottom, then mess around with it, complete the square. And then the 2 I just gave you, and then there's one more down here. You have to find the antiderivative of that. Anyone have an idea of how to find the antiderivative of that? God dang it, what is that thing? It's annoying.
That looks like what, U sub, isn't it?
What would your U be?
What was that?
What would the U be?
It looks like the U would be. Oh man, yeah, no, I'm lost.
Could you integrate that by parts?
What would you use?
I mean, I'd take the derivative of natural log x so I could get a 1/x. And then antiderivative of the other, because I can find that pretty easy. Would just be -1/2, so it'd just become a +1/2, yeah. And then those multiplied.
That's that you can put together and integrate.
Yeah.
Yeah. So parts.
Jeez.
But notice again that we
It's
have
got the funny
we have
numbers.
numbers, which means we'll have to do something additional. It's not going to be a big deal. The numbers aren't going to be a big deal.
So-
the main problem is still going to be, you got to find the antiderivative.
Are those something that like you plug in afterward or something?
Yeah.
Or is that telling, are those, okay.
Yeah,
Yeah.
basically the numbers, what we're going to do is we're going to find the antiderivative, and then
Uh-huh.
we're going to plug those numbers in and then do a subtraction, and that's it. So
Weird.
it'll be that part will be easy.
Okay.
Yeah, so that is a review. Let me see. Okay, good. Let me see, the actual exam, oh, this is an older one. Oh, yeah, okay, so look, this is an exam I've given in the past. This is like 6 years ago. Look at this first one. That's trig sub. That's a trig sub. It's a pretty clean trig sub. Oh, wait, it's 12:45. You can go if you gotta go. Sorry, I'm just sitting here yapping away. Let me make sure there's no one sitting in the office hours. Yeah. Here's another trig sub. This was one where I gave you one like this in class where you have to complete the square here first, then do trig sub. And then this common theme, I love giving these problems, linear over irreducible quadratic. I really like these problems.
To be honest, those are the ones that are tripping me up the most right now, so.
Really? Okay.
Yeah,
so-
like I hit the end of that big long problem and it's got, oh, linear over reducible. It's a pretty small one and I'm sitting there stumbling over that shit.
Yeah. So you'll want to make sure you work those kinks out. This one here, that's partial fractions. You do not need long division. So you can go right to factoring the denominator and then setting up your, figure out your ABC stuff. This one does need long division. But after the long division, you get to partial fractions. Look at that. This one has an infinity up here. Don't know if we'll be there when we get to this point. There's an infinity up there. That's a problem because, well, yeah, that's a problem. And then this one's a problem too, because you try and find the antiderivative of that. That's pretty simple antiderivative for this one because you just do a u sub. U is x squared minus 1. The derivative is right up there. The problem is you can't plug 1 into this, right? Because if you plug in 1, you get division by 0. So there's a problem at 1. So we got to deal with that somehow. We haven't talked about that yet, so don't worry.
Yeah,
about it.
is that what that means?
Yeah, so we're going to have issues. So yeah, but this just gives you kind of an idea of what I expect, right? Notice that none of these tests have had something where it just has like sines and cosines, tangents and secants. It's because when you do the trig subs, those all turn into trig integrals. Those all turn into like sine, cosine, secant, tangent stuff. So you're going to wind up doing it in here anyway.
It's kind of like when I was going through that homework, I hit a certain point and realized that, man, if I just jump ahead to the second half, I will get all of this same practice.
Yeah, that's true. All right. When is our next test? I feel like it's close. Yeah, it's closer than you want it to be. 2 weeks from today. 2 weeks from today, right before spring break.
Oh, that could ruin someone's spring break. Once we get the grades back.
Yeah,
I'm sure it would ruin mine. I'd be upset. Damn it.
we could do it after, but then you're going to be wanting to spend your spring break like working, and
Studying.
studying and
Yeah.
stuff. Then I really do ruin your spring break.
Yeah. Well, the homework, sir? It's oh, I see.
Yeah, so for the homework, I mean, now you're pretty much free to try all the problems here from partial fractions.
No.
Yeah, 6.3 is what you want to be, wait, is it 6.3? Yeah, 6.3. I don't know why I put 6.4 on there. Yeah, don't worry about 6.4 right now.
Okay.
Okay, y'all have a good one. I got to get to my office hours.
All right. Thank you, sir. Have a good
All right.
rest of your week.
We'll see ya.
Thank you, sir.